A wise man once said, "I got 99 problems." And I can relate to that in some sense, because on a day-to-day basis, I run into problems. I run into things that aren't as easy as they should be, or things that I want to be better. And I suspect that because you are all in this room on a Saturday, you also have problems, and you also run into things and want to use software to solve them. And today I want to talk about ways that we can use software to solve our problems, and specifically to give those software solutions some intelligence using data. Now, the motivating example, and the one for which this talk is titled, is a job search helper thing that I made. And basically what happened was, a few months ago, I was passively job searching, which is to say that I wasn't actively out there knocking on people's doors and handing out resumes. But I was curious to see if there were any particularly excellent jobs in my area. And so I went out and tried to sign up for different job alert things that would give me the coolest jobs, and I couldn't find anything that did exactly what I wanted to do. So like any good engineer, I built it myself. And I built this little email newsletter that I would send myself every week that essentially had the coolest sounding jobs in my area, and then I could go through and just review those jobs. It was basically a way to filter out a lot of the noise. And so we're going to use this as sort of a case study and motivating example today to talk about a process that I've gotten to use a few times that has worked for me, and I wanted to share with y'all to hopefully provide some value in your own lives. So this is how we're going to be doing that. The astute among you have probably noticed we are currently in the introduction. After that, we're going to talk about asking the right question, basically phrasing questions in ways that computers can help us answer them. Once we do that, we'll talk about ways to gather the data, and then we'll analyze that data, and then finally deploy the insights that we gather. And here I don't mean deploy in the sense of we're going to put the code on a server somewhere. That part is interesting. But more relevant, I think, to this discussion is how do we get a number to be something interesting to a person and express it in a way that people can understand it. So as for me, I'm originally from this part of California, Bakersfield, California. It's the really boring part, but it was a great place to grow up. And then I left and went to Baylor University, where I studied computer science. Really enjoyed my time there. And while I was there, I sort of got bit by the data bug, if you want to say it that way, and got to do some research in an autonomous drone lab that was really exciting. Did some research with collaborative filtering, which is a recommender systems kind of thing that got me started down the path of the thing I ended up building for this. And probably another relevant thing I got to do while I was there was I taught a computer sign language, which was really fun. And then over the summers, I would go do internships at various places and learn a lot about software and good engineering practices and stuff, and tried to unify this all together. And then after I graduated, went and started doing some data engineering work. And now I actually work at Indeed, which is the world's largest job site. But interestingly enough, literally everything that I'm going to talk about today is completely unrelated to my job there, other than the fact that I do data stuff there too. But all the code I wrote for this I actually wrote while I was at my prior company. So let's jump into today. The most important thing on this map is the fact that we're all here in this room today to talk about these kinds of things. And so I'm really glad that you were all able to come and honored by your presence here today. So that's all the boring stuff. Let's get into the cool part. The first step in this process is to have a problem. And this is the easiest step because it's the one that just comes naturally. It's the one that you bump into on a day-by-day basis. And for me, I bumped into the problem of job alerts are too noisy. There's too many jobs for me to reasonably look over in a short amount of time. I've also run into problems where I was trying to figure out how to get my energy bill lower, or trying to figure out how to get home from work faster. And once you have a problem, the next thing you're going to want to do is start to think about solutions. And in order to do that, what you need to do is understand the ways we can ask computers questions and get useful answers back from them, which leads us to the fun buzzword of the day, machine learning. If you have heard the phrase machine learning, please raise your hand. All right. Yeah, it's a buzzword. We've all heard it. It's great. If you feel like you have used machine learning in a substantial or interesting to you way, raise your hand. Awesome. Some more great hands. This is awesome. One last question. If the phrase approximation generalization trade-off means anything to you, That's fine. We're talking about it later. Just wanted to know like what to go into. So thanks for your participation there. So what is machine learning? There are a few different things that comprise it, and I'm going to talk about a subset of it today. There are a few kinds of algorithms broken into a lot of different categories. This is good enough for the day. There's a type of algorithm called a supervised algorithm in which you are basically feeding training data into a computer, and that training data has a number of features that are like input values and then a number of output variables. And so here on this graph, what you see is that the x-axis is age and the y-axis is net worth. The example problem that this is basically, I'm a bank and people are coming to me and asking for a line of credit, and I'm trying to decide whether to extend them a line of credit or not. And one way you could theoretically do this is to just look at your past history and say, okay, when people have come to us in the past and asked for credit, how old were they, what was their net worth, and did we extend them credit? And that's what this graph is displaying. That's what this graph is displaying, is the age and then the net worth, and then the plus or minus you can think of as a 1 or a 0 of whether or not we extended them a loan. And then the machine learning part of this is to basically draw a line through this data. And it doesn't have to be a line, but a line works for this, so we're just drawing a line. And you'll see here that because in the past we had someone who was 90 and did not have very much money who came to us and asked for a loan and we rejected them, if someone who was similarly aged and similarly net worth came to us, they would be below this line, and so we would not extend them a line of credit. So that is an example of a classification problem. Because there are sort of classes involved. There's a positive, we did extend them a loan, or a negative, we didn't extend them a loan kind of question. And classification is great for when you're trying to find out what kind of thing something is. Now, if you're trying to find out how much of something is, so if I was a bank and I was trying to decide how much credit should I extend to a person, you're going to have to use a regression algorithm. And regression is very similar to classification in that you still have a number of input features and an output of some sort. And here it's a little bit confusing because here only the x-axis is an input. So on this last slide, both x and y were inputs, and then the plus or minus was the output. But here we're just saying that the x-axis is our input of net worth. So someone comes up to us and they say, I have $500,000, how much of a loan can I get? And then the x's are merely positions, the x's aren't themselves significant. But you can see, for instance, someone who had, not very much of a net worth down in that bottom left-hand corner only got a loan of like $1,000 because that was a more risky person, for instance. And so as a bank, I have all this historical data, and then I could train some sort of algorithm that would draw a line again. And we could then say, if someone comes up to us and has a $750 million net worth, we can look at where they would land on that line on the x value. And just the y value then would be the size of loan we extend them. So here it looks like it would be $75,000 or something. So that is another kind of supervised machine learning algorithm. There are also unsupervised algorithms. One such algorithm is called clustering. And in clustering, you have a bunch of data points. And I apologize that this is not the same example, but you can imagine that that each of these dots is a customer. The x-axis could again be their age, and the y-axis could again be their net worth. And maybe it's computationally prohibitive to do the calculation on the full data set, but you could theoretically cluster people and say, there are like 11 kinds of people, and depending on the kind of person you are, then we could make a decision based off of that. And clustering, you're not trying to get a specific output, you're just trying to understand the data better. And it's often useful as a pre-processing step, so you might, again, have someone come in and they have a certain net worth and a certain age, and you could say, this person is really similar to this other kind of person that we've seen that we usually extend credit to, so let's extend credit to this person. There's a lot of other stuff that is machine learning and stuff that is time prohibitive to talk about today. So this third of the slide is here to prevent angry tweets, because there's a lot of stuff that is really interesting and really cool that just doesn't quite fit in today. So once we know the kinds of questions we can ask computers, we can figure out a way to phrase our question. And in my example, I'm thinking, okay, job alerts are too noisy for me. What do I want? I want to know what are the coolest jobs. Okay, well, maybe I can ask a computer, given my input of a job title, give me the output, does it sound cool or not, just as a 1 or a 0. And that's a way we can phrase our question in a way that a computer can actually help us with. So now that we have this formulation of our problem, we can jump into gathering our data. There's a lot of data out there. The best thing to do is just search for it, because that's how we are these days, is just go out and Google it. And for instance, one time I was trying to determine my energy usage, and I thought it was probably going to be correlated with weather. So I was looking for weather data, and there's this government agency called the NOAA that has this massive weather data set that you can just download and use, and it's great, and it's documented. And so it's very likely that you'll get out there and search for something, and there's already a government agency whose job it is to collect this data, which is really exciting because it means you then have to do less work. In the case where you don't find something that already exists, through searching, you can also try various websites. Data.world is one, and they have a bunch of data sets on there. Kaggle Datasets also has a similar feel to Data.world, where they have a bunch of existing data sets about usually more broad things. They don't tend to be as specifically relevant, if that makes sense. So they'll have things like crime data on their website, and they'll have it in some useful format, which may not be particularly useful to you, but it might be useful if you're trying to figure out where to buy an apartment and you want to look at crime statistics. That might exist. So there's a case where you may or may not find the data, and if you don't, you're going to have to create it at some point. I like using spreadsheets for this because I can have them on my computer, and I can have them on my phone, and just anywhere I am, I can go and collect more data. Other than that, there's a tool called If This Then That can be useful, especially when you're collecting data on your own personal habits. For instance, when I was trying to find out when the best time to leave my office was to minimize my commute time, you can get a little button that If This Then That will make for you. And when you click it, it'll log your location and the current time into a Google Sheet. And so what I would do was, when I left the office, I would press the button, and then when I got home, I would press the button again. And in that way, I could calculate how long it took me to get from my office to my home, and at what time I left. And then I could have all this data about, okay, you leave at this time, that's your input value, and it took you this long, that's the output value. Now, I know that Google Maps can also do this for me, but I'm a nerd, and we're at a developer conference, so I think it's fair to over-engineer something. Beyond that, web scraping is another great tool. What this basically is downloading a website and picking out the important or useful bits. There are some legal things here, and I am not a lawyer, so do your own lawyer stuff, but an important tip is that when you're trying to scrape a website, look at their robots.txt, which is to say that whatever website you're on, take the domain name and then put /robots.txt, and it'll have a listing of basically the places you're not supposed to go if you're a computer. And please obey that, and you're probably fine, but again, I'm not a lawyer, and this is not legal advice. And it may be the case that you combine these two methods, and that's actually what I ended up doing for this project. Was I web scraped a bunch of job titles and the companies and a link that I could go look at something. And then when I had spare time on the bus or something, I could click through the links on my phone, read the description, and then come back and say whether or not the job sounded cool. And so these, columns A through D here are existing data, and then column E is the augmented data that I'm creating myself. You're going to need to clean this data. I heard it once said that there was someone speaking at a conference, and they said, 50% of data science is cleaning data. And when he got done, he had all these people coming up to him and said, that's ridiculous. At my job, it's 80%, because it's just so much of the effort is spent cleaning the data. And there's two tools that I highly recommend if you're in the Python ecosystem, which are Pandas, which does a great job of loading data into a tabular format in memory. I've heard it described as in-memory SQL before. And then scikit-learn has some stuff built in to massage data into formats that computers can more easily understand, that we'll get to in a moment. Now, you may remember from before these graphs that are numeric data. Computers are good at numbers. Computers aren't as good at words. And so you may think, well, if I had someone's age and net worth, I easily see how those are just numbers. But for something like a job title, where I'm trying to say, is this job title cool or not, that is different. That doesn't feel like I can just type that into a computer and have it fit that into a graph, because I don't even know how that mapping would work. And so we're wanting to do something like this, where we take the input of the job title and the output of whether or not it sounds cool and turn it into some set of numbers. And we're wondering how to do that. The great thing is that when you run into a problem like this, when you're trying to solve your own problem, there are a wealth of giants whose shoulders you can stand upon. And so you can just Google text representations for machine learning, and out will pop this, probably. This is the idea of word count vectors, or bag of words. And essentially what's happening here is you take all of your job titles and you keep track of either all of the words that are used in every single one, or maybe the 300 that are used most frequently, or something like that. And then you stack them all up, and you go through each job title and count up how many times each word occurred in a given job title. So we can see for this first job title, Senior Web Applications Developer, that the word engineer occurs 0 times in this job title. And the word web occurs 1 time in this job title, et cetera, et cetera. I'm not going to bore you by enumerating this matrix, but you see how this process works. What's that? Oh, okay. Anyway, so you can see how we get these word count vectors, and that's a fancy way of saying strings of numbers that count up how many words are how many times a word is in a given job title. And that gives us exactly what we were looking for. We're able to go from the job title and the output variable of whether or not it sounds cool to this set of numbers, where these first 10 numbers or whatever are the number of times that a given word occurs. So maybe that first number is senior. And then that last number there is a 1 because that job title sounded cool to me. And so now we can start actually analyzing this data, which is great. There's a few tools that I recommend for doing this kind of work. Jupyter is really great. It's an interactive programming thing, essentially. You run it on your computer, and then you can load a browser up and do stuff, and it'll show you the output of it immediately, which is super helpful because it's nice being able to see what the data looks like, and it's nice being able to understand what your next step should be. You can also do neat things like drawing graphs. That's what's shown in this screenshot. And it's just a very useful tool to use. The maintainers of this project have put in a ton of work to make it basically the de facto interactive, iterative programming tool for data science, data analysis people who are using Python. I think I spend a lot of my day in Jupyter Notebooks at work. I also definitely recommend pandas and scikit-learn, which we talked about earlier, so I won't talk about those again because you already know. But it's nice to not have to re-implement all these algorithms from scratch because other people have already done it for you. So this is just a little code example to show you how easy this kind of stuff can be. Oftentimes we talk about machine learning and it sounds really scary and foreign. And when you actually look at the code, you realize this is something anyone can do. This is not complicated. It's just a little bit of understanding how these algorithms work. And then reading some documentation. So I often call things X and Y because I'm just used to that nomenclature. So I take our job titles out of the data set that I have and I put them into this X matrix. I take whether or not they sound cool and put them into this Y vector. The next line is a count vectorizer, which just does that word counting thing that we were talking about earlier. And then you can just say, okay, take this matrix and turn it into the word counts, which is what's happening there. And then you create a model, you fit the data to it, and then you can just call .predict on it. And it will give you this beautiful array that I have here bolded that says, okay, job 0 did not sound interesting, et cetera, and then maybe job 4 sounds interesting. And you can get this all out very easily. It's not a lot of code to get a lot of value. The thing you're going to want to do after you've been able to gather your data is just do the simplest thing that could possibly work. And there's good reasons for doing this that we'll talk about now. So earlier, no one knew what the approximation generalization trade-off was. My hope is that you are about to learn. The idea here is that the better your algorithm approximates the input data set, the worse it is going to do at generalizing to data that is outside of your input data. That sounds a little bit, that's a little bit hard to just say and have it be understood, so I made a little graph that I think will help. And the process of making this graph is I first generated a true data set. You can see here is the blue line. And this basically says that when we enter 0, the value that comes out is 0. And then at the far right end of the scale, when we enter 10, we expect negative 20 to come out. This is a very simple function that we're trying to estimate with our machine learning stuff. It's purely for illustration. And you can see then that I generated 10 data points from this blue line by just adding a little bit of noise to each point, because the real world is fairly noisy for a number of reasons. And then I fit 2 different models. The red line is a nearest neighbor model, which is a more complicated model than the linear regression model. And you can see that it does an excellent job of representing the data set that we gave it. It is matching perfectly at every single data point there, which is great. But you can also see that it is not very close to the truth. And if we were to draw more data points from the same truth, we would basically find that the red line isn't doing a good job of generalizing to data that it has not seen yet. This would be like if you were taking a practice test for a math class and all you did was memorize the right answers to each question. You would do great at the practice test, but once you got to the real test, you would do horribly because you don't actually know how to do any of it. You just know the right answers. By contrast, linear regression is doing a much worse job of approximating the input data set. It is way far off. If you see for x value equals 0, it's like 5 units underneath that data point. And then similarly from the range like 2 through 4, it's not doing a great job there either of approximating the input data. However, one thing that you'll notice is that line on average looks a lot closer to the truth than the red line does. And the reason for that is that it is better able to generalize to out-of-sample data, essentially. And what we can see here is that the red line is doing what's called overfitting, which is when you learn too much of the noise in your algorithm. And that's a real problem that is easy to run into, especially when you're using complicated methods. There's a lot of really interesting stuff on Hacker News that will have you believe that you should use TensorFlow and PyTorch and all these really interesting and exciting deep learning frameworks. And they are all very interesting and very exciting and have great applications. However, they are often more prone to overfitting than some simpler models. So it's great to just start with something simple, and you can move on from that if you need to. Another benefit is that it's often just easier. It's a lot easier to get scikit-learn running on a Mac or a Windows computer than it is to get PyTorch or TensorFlow to get running. Aside from that, it's just easier to, when you're iterating through this development process, it's a lot easier to have something that trains really fast, and you can try out a bunch of different ways of representing your data or different ways of sampling it, and have that be fast rather than something that takes a long time to train. So in practice, what this means is just start with something simple. Linear regression and logistic regression are both great models that are good places to start. And you can use them both for actually regression or classification depending on what you need to do. So we've gotten to the point here with this that we're in the deployment process. And by this I mean that we have these numbers, right? We got those numbers out of our model, the 0 and the 1. But if I were to just look at 0, 1, 0, 1, 0, 0, 1, that doesn't do anything for me. And I also don't want to have to run that code myself every time. And so one thing that I was thinking, because I am my own user and I can kind of read my own mind, was I wanted to build this email, which you already saw earlier, spoiler alert, sorry. But basically the thought was I don't want to have to run this thing on my own, and I want to get just the relevant and interesting jobs. So what I did was just put it onto a server that I rent and have it run every week, run the code, and then just the jobs that are interesting, it formats them a little nicely and puts them into an email and sends them off to me. And this is a good thing to do, is just build something simple and ship it, just get it working. And because the next step here, and if you've gone to any of the talks that people have been doing about like agile practices, this should sound familiar, because just because we're using data in this software does not make it any less software. We still need to test out our product. We still need to test out our products. We still need to try them on actual users. We still need to figure out what doesn't work and what does work. We still need to iterate. And we still need to iterate again and try something new. And we need to iterate even another time. And we just keep moving and keep trying new things until we get to something that works really well. So, to summarize, because that was a good amount of things, step one is to have a problem. Find something that you want to solve that sucks in your life. And then once you have that thing, phrase it in a way that a computer can help you answer it. There's a lot of things computers are good at. If you have a problem that you can rephrase as a how much or what kind of problem, those are really great candidates for a machine learning application. Once you do that, you're going to need to get some data and then just try the simplest thing you possibly can and see how well that works. And you can test out and iterate from there. But it's really important to get these things in front of users and to just try new stuff. So that is the gist of what I have for you today. If you want to learn more, there's a textbook called Learning from Data that is really excellent. It does a good job of treating machine learning in a good way, because a lot of times when people talk about machine learning, it comes off as a bag of tricks. This book does a good job of helping you understand some of the theoretical underpinnings that help these algorithms work and help researchers talk about them. And then from a less academic but more practical side, there's a blog called Practical Business Python where the author talks a lot about data visualization and how to do useful stuff with pandas, and it's extremely useful if you're trying to learn this stuff. I've learned so much from them. Also, sponsors are good. We like them. So if you're looking for a job, I'm sure some of these people are hiring, and we're very grateful to have them here. And then I would be remiss not to thank my employer, which is Indeed, because they paid for me to be here. So thanks to them. Other than that, I hope that you've gotten something out of today, and would love to meet y'all afterward. If you have any feedback, if it's negative, please email me. I would love to hear what I can do to make this better. If you have any positive feedback, please tweet it, because that's good for me. Beyond that, I hope you've gotten something out of today, and go solve your problems. Yes, I will put these slides up. I realized as I was starting that I haven't put them up anywhere yet. Would you rather me tweet them and put them just on my website? What is easiest for you? Okay, I'll tweet them once I have them up, which should be in a few minutes.
So, does your Twitter handle insinuate that data is your middle name?
The first line of my Twitter bio is data is my middle name. So yeah, yeah. So I'm glad that joke works.
My name is Samuel Data Taylor.
Yep, just about. Yeah.
Iterating through the data, so a little bit I know about this. I'm starting the training set, and then full set of it. How do you iterate and not over model because you're training set over and over?
Yeah, so that's super important. To rephrase the question, or to restate it, if you are trying out a bunch of different algorithms and seeing how well they perform on a given test set, you'll often come out with the best algorithm to predict that test set, but then you've sort of overfit to the test set rather than overfitting to the training set, and you're still in the same problem. So the best thing to do there is, and the thing that is recommended in this textbook, is to avoid what they call data snooping, which is anything that is going to influence the way your model ends up being built. Cannot be basically used to evaluate it. And if you're using a test set to test your data, or to test your model at the end and see how accurate it is, and then from there you change something and then test again, that means that data is no longer valid as a way of testing the accuracy of your data. So a lot of times what I've seen people do is actually they'll split their data into 3 sets, and they'll take like 70% of it, and that's their training data, and they'll take 15% and they'll use it as like a validation set to test to like optimize hyperparameters in their model. And then at the very end, they'll test it on a test set and see what happens there. So I've seen people do that before as a way of avoiding that problem of overfitting to the test data set. Yeah. Anyway, if anyone else has any questions, please come up to me. I'm friendly, I promise. Thank you guys.